We have DeWayne Wilson presenting on Washington DOT's Steel Bridge Paint Program. DeWayne Wilson is the Bridge Asset Management Engineer for WashDOT.
Presentation on the bridge painting program. So all you construction engineers that were hoping to see how we paint a bridge and all the nuances, sorry, this is the asset management side of that. So here's kind of our agenda. We're going to talk about the network of our bridges, a little bit of paint history, inspection, how we determine our needs, priorities. And then I got a little segment on let them rust and replace, design and construction, and then maintenance, bridge washing, and then we'll finish up with some questions. So as far as Washington State's network, this number is always in flux as far as how many bridges do we have, but as of July of last year, 3,322 NBI bridges with the replacement value of $58 billion. From asset management, it's always important to kind of put context on the system. How much does a bridge cost to replace? Because in preserving those bridges, then you can kind of tell the story of how valuable preservation is in the program. And so steel in Washington State on the state highways represents about 23, almost a quarter of our population based on deck area. And then if you just look at the steel bridges as a whole, you can see that that inventory is getting older. We have now 56 bridges that are over 80 years old with the replacement value of about $2 billion. And then there's another group coming right along beside that, right behind that, another 87 bridges that are about $4 billion worth of bridges there. So we got a significant inventory. We don't have $14 billion to replace these steel bridges, so we need to do whatever we can to preserve them. As far as our network goes, we have about 300 steel bridges, but there's these little nuances in the group. We have some shared border bridges with Oregon and Idaho. And we have the Tacoma Narrows Bridge. We have some weathering steel bridges that are not painted. And then we have a few bridges that we're going to replace eventually. So as far as groups of our steel bridges, got to put this in context because it's kind of important because not one size fits all on all bridges. We have a healthy population of steel trusses, 119 of those, 94 through trusses, and these become real challenges to preserve and kind of our main focal point right now because of their size and expense. You might recognize a couple of the lower bridges or the Seattle bridges. Your left is the Aurora Avenue Bridge. The other one is the Ship Canal Bridge on I-5 in downtown Seattle. And then we get into the more common girder bridges. So you got the welded, riveted girders, you got the rolled girders, so quite the variety there. And then we have a few steel arches. We had a small group of the tied arches, but they kind of fell out of favor with some of their fatigue cracking issues. And then we got some deck arches. In our weathering steel bridges, we have 18 weathering steel bridges. 13 of those are girders, 4 boxes, and then 1 steel truss. 5 of those have been painted with a clear epoxy because what we found, in some cases, the engineers really didn't think out where they put these unpainted weathering steel bridges. They were in environments where a lot of water, a lot of moisture, and so it kind of overwhelmed the weathering steel. And so we needed to calm that down a little bit, so we coated them with some clear epoxies. And then we got the iconic Tacoma Narrows bridges. You can kind of tell the difference between the old and the new as far as look at the towers. The one on the upper part of the picture is the older bridge with the steel towers. The one closest to you is the newer bridge. It has concrete towers, but it was made to kind of look the same. And then we have one other suspension bridge on a smaller route up near Mount St. Helens. The Tacoma Narrows bridges, the older one has a full-time maintenance crew, and they do full-time painting on that bridge. Then we have some movable bridges, 15 of those, varieties. Almost every one of those movable bridges is unique in its own case. Here I've shown some paintings. We had an architect in our office that was also an artist. He painted each one of our movable bridges, so I thought I'd show off a few of those pictures. As far as paint history goes, we started in, just like about everybody else, with the lead-based paints. and those kind of fell out of favor. You couldn't get them anymore after the early 90s. We still have 73 bridges with those paints on them. You can see in this picture, we overcoated year by, every about 6 to 7 to 10 years. This particular bridge, I thought that was a good picture because it just shows the millage, the thickness of the lead paint on there, the alkylid. And so we have this database with this little donut. We keep track of when we painted the bridges, and you can see there. So in some of these bridges, when the last paint job happened, then there's a big gap. So on this particular bridge, it was like 22 years since it was last painted. Well, it had been used to be painted about every 10 years, so now starting to get a little bit more corrosion, more deterioration because of that. Then we had these zinc primer vinyl systems, 22 bridges with those, and they were discontinued, but they actually have held up pretty well. We've gotten pretty good service life out of them, with the oldest 48 years, and the average age is 35. So far, we haven't repainted any of these yet. And this is kind of our standard when we paint today, is take it down to bare metal, use the zinc primer, moisture-cured urethane systems. These systems have held up really well. In our state, what we do is do some stripe coats to make sure those edges and rivets and different things, so you can kind of see that with the different colored paints in this picture. So in asset management, we want to know, what's the service life? How long is something going to last? So the lead-based paints, generally in the 15 to 20 year range once they start breaking down, especially on steel trusses. And then the zinc moisture-cured urethane, somewhere between 20, 25, maybe a little bit more than that. We don't have a lot of history on steel trusses with these paint systems yet, because we just started getting into them, probably getting down to bare metal in the later 90s, early 2000s. In the girder bridges, when we use the zinc primers, we're getting really good service life out of those. So as far as paint inspection, and this isn't the contracts, this is just when our crews go out there to inspect a bridge with the National Bridge Inventory inspections. We've created some BMS elements to track the paint condition. So we basically have 3 condition states. Condition state 1 is good. Condition state 2, the paint is peeling off, but we don't have any active corrosion yet. And then condition state 3 is active corrosion. So it's kind of hard as a bridge inspector to go out there and rate the paint, because you're kind of worried, or not worried, but you're more concerned about the structural capacity of the bridge than the paint condition. And so we just ask them, hey, just do your best when you're out there, quantify it the best, because in asset management, we want to just know differences. So we want to know those bridges that the paint has failed, and so that we can kind of group those together and maybe come up with a priority. So here's an example of a bridge in condition state 1. The little donut up there kind of shows you when it was painted. It was originally painted with a zinc-based system, one of the first ones I could document in our state. And then for some reason, they just overcoated after about 9 years, and then we haven't repainted it since. This bridge is up on our Highway 20 in North Cascades Highway. The inspection, when they went out there, they found 200 square feet of surface area that had some issues on it, but no real exposed steel yet. So the bridge is in good condition, the paint at least, so we'll keep going with it. We're not going to schedule it for repainting until the paint starts breaking down. As far as our needs and funding, we created these groups, kind of like pavement management system, and we created 3 groups that says, okay group, the ones that are going to be due in the future, and the ones that are past due now. And so that kind of mirrors, or it kind of goes along with the condition states. The past due ones are the ones that have basically bare metal, exposed steel, rusting. And the ones that are due are the paint's breaking down, and we're going to put them on our list for the next 10 years. Funding, and you need to know, what's the cost? And so I'm more concerned about the overall cost, the total project cost. Right now, it's averaging about $65 per square foot of steel when all is said and done. And so then we can take that cost, apply it to our network, and then come up with a list of needs. And this is just kind of how we do it. We put out a publication called the Gray Notebook. And so every July we write up an article, we look at our system, we put things in these little categories. Nobody reads the article anyway, but at least I can have a place where I can go back and say, okay, what's the funding level that we need over the next 10 years? You got your contract work in progress. You got the ones that are past due. We got some border bridges that we share. And then you have the ones that we're saying, okay, these are going to be due in the next 10 years. You total that all up, and it comes up to about $775 or $777 million worth of needs. Take out the contract work in progress, and our 10-year painting needs is $716 million. Now we go look at the funding side of the house. Okay, we need $716 million over the next 10 years. They say, well, we're going to give you $515. But then you got to look at how that's distributed over the next 10 years. And it's backloaded instead of being front-loaded, it's backloaded. So you can see the next 5 years, we get $150 million. And then after that, we get the $366. Well, the bridges don't really care, and the rust doesn't stop. So the bridges are going to continue to deteriorate over that time. It's more than likely we're going to have repairs, not just painting, as the bridges deteriorate. So as far as how do we determine priorities? Okay, you got these needs, you got the funding, so how do you determine your priorities? What we did in our state, and this is just who I am, I put things in kind of little buckets. So I start off with saying, okay, you can complete the construction, that's number one. And then you got these border bridges. Well, it doesn't work if either state says, I'm not going to prioritize that border bridge. Well, that doesn't work because we split the border bridge cost 50-50. So between Oregon and Idaho and us, we have to agree that on the time, the schedule to paint those border bridges. So we put those up higher as priority. And then the next ones are just a bunch of steel trusses in different categories. Past due on the main freight routes. I want to get to those before they have a lot of repairs needed. And then we got the past dues that go to some of our islands. We got a few bridges going to islands, and that's the only way on and off the island. It's pretty important for those people that that bridge is preserved. And then we just keep going and ranking the different steel trusses. And then here's another group of those just to show you the number of bridges, the area, and the cost. So with the funding, we're basically going to get down over the next 10 years just to this group of steel trusses. So there's a lot of other bridge types and a lot of other bridges that are not going to be funded for painting. And then this is just a little map of showing what's going on today. We got some bigger projects. You can see that they range anywhere from a few million to all the way up to 30 million. Aurora Avenue Bridge was a big bridge, and so it's like $55 million. In order to right-size the project so contractors can get bonding, we had to do it in 2 stages. So we did a stage 1 and a stage 2, and then a variety of other bridges around the state. And then the list gets a little shorter due to funding. So next year, we only have 3 bridges on the list that are scheduled to be painted. Let them rust and replace. So I was talking to a materials engineer in our DOT about 10 years ago, and he just said, I don't know, what's the big deal? Why do we need to paint bridges? Let's just let them rust and replace. And I kind of scratched my head, and I didn't know how to answer him at the time, but really it's an economic decision. It comes down to finances. On this particular bridge, it's a small bridge, an older bridge. It was due for replacement anyway, but here's kind of the history. Built in 30, last painted in 78, and then it became poor in 2008. And so then it became poor condition, and the load rating group got a hold of it and said, okay, we're going to rate it for these different trucks, and that's in 2010, you can see the one posting sign. And then 2012, it got a little bit more severe. Here's some of the issues going on. We had a corroded stringer that basically you could put your hand through. And then this picture shows some corrosion that was going on main connections there. And then we had these issues where the local fire trucks didn't know that they were a truck, or they didn't know that they were over 7 tons. I don't know which one it was, but the public wasn't accepting the signs. And so we said, okay, to keep the public safe, we're going to put a Bailey bridge over the bridge. And so we reduced it down to 1 lane, but at least we could put full loads on the bridge. And then in 2019 here recently, we just got the new bridge built, and then you can see the old bridge. The other complicating thing on this bridge was it was a historic bridge. because it's one of the last pony trusses we have in our state. So we put it up and offered it. Hey, anybody want this old pony truss bridge? We actually had a contractor in Walla Walla said, sure, I'll take it. So we cut it in half, put it on a truck, going to take it over to Walla Walla and put it across the river in his property and then have a big party when he opens it up. So here's some other bridges that we're consciously saying, yes, we're going to let these bridges rust and replace because we know these are on the replacement list. But we can't do that with all the other bridges. The inventory is just too big. It's going to cost too much money. Here's an example of a bridge that was built in 1940, last painted in 88, looking pretty rusty. It's also a pony truss bridge. And so I did this little math economics thing and said, okay, if we painted it today, it's going to be $1 million. If we wait another 10 years or so, it's going to be about $3 million in repairs and painting. And then if you wait another 10 years after that, the replacement's $6 million. So thankfully we get the $1 million, we paint the bridge, and then we get to defer replacement off into the future. So design and construction. So one of the things that's happening today is that nobody wants to give up anything. So we want to keep the traffic on the bridge, but then we got to paint the bridge. We got to put all this containment on the bridge. And so it's becoming more and more challenging to meet all these constraints. Here's a bridge on I-90 over the Columbia River called the Vantage Bridge. So it's a 4-lane bridge, pretty unique bridge. In order to paint the bridge, we needed to put another line of barrier on the bridge. So the weight control was very important on this bridge. We did a load analysis, and then we gave the contractor a certain weight range, and then we said, okay, you can only put this much weight on the bridge. Well, then we had this drone that went out there and took a picture of the project, and we noticed, hey, what's that semi doing there? Hey, what's those man lifts doing there? So there was a lot of confusion between the project office and the plans on what the weight they can do on this bridge. Fortunately, we got away with it. It didn't overstress the bridge by doing this, but it was clearly out of bounds from the contract. Another challenge is movable bridges. Here's a vertical lift bridge. The boat owners want to call us up and say, move this bridge in 2 hours. Well, we say, well, how are we going to do that? Put paint containment on the bridge. So we're having this real debate between the Coast Guard, the boat owners, on how we're going to paint this bridge, but then still keep it open. So here's just kind of a before and after picture, the rust, and then you got the painted section. What we're finding more and more now is when we're getting out there later in the game, when we go down the bare metal, we're taking more of the section of the steel off. So it's becoming a real challenge for our load rating group to identify and then say, hey, what's going on afterwards? Here's a bottom chord of a steel truss that has all these pinholes in it now. Here's another picture. Here we painted a bridge. It was in fair condition, but after we painted the bridge, the inspectors rated it down to poor condition. So now we have to go back and figure out what does it take to raise it back up into at least fair or good condition. This is an extreme case where we had a bridge with columns, and this is a support across the columns. And then the designers originally put this W member up on its edge, and so this member got all filled up with leaves and dirt and garbage. So by the time we went out there and cleaned it up and painted, there was nothing left. They blew right through the web. So bridge washing. This is a really important component. For a long time, we couldn't really figure out all the environmental issues and problems, so we kind of stopped cleaning our bridges. Well, we had a little incident in 2013 with the Skagit River Bridge. Truck hit the bridge, span dropped. But then when we started looking at the bridge and how dirty it was, that was like, that's just not acceptable. So we got all our heads together, we got the environmental people together, and we came up with a way to getting these bridges cleaned. We came up with a discharge permit, and as long as we clean them the first time really well, then we could flush them every year when we have the high water flows. So here's the bridge washing program through our maintenance groups. So we're hitting the steel trusses and getting them washed. I think it's page 7 of this guide. You might recognize this picture. It's something from the Olympic region, Chris Keegan's group. One of the things after you wash the bridge, it's nice to touch up areas that are deteriorated. And this is a picture I just pulled off the internet. This bridge has everything going against it. 12'9" vertical clearance, posted for 3 tons, and then finally closed. Eventually, all bridges are going to have to be replaced. We want to put that off as long as possible. And painting bridges at the right time is one way that we could preserve our bridges. So with that, I'll end up with a picture. If anybody recognizes that, Mount St. Helens decided that we no longer needed this bridge. In 3 days, we'll have the 39th anniversary of Mount St. Helens kind of blowing its top. But there was quite a few bridges on that corridor that Mount St. Helens took out.
Why would they do that?
Well, there's a whole lot of things going on, but
Yep, sorry. I asked why you were funded backload funding. It just seemed backwards to me, and I wondered if that was for fiscal flexibility.
well, when you take on quite a few large projects and you bond them, then you have to pay those back. And so really our debt service right now is a lot of our funding. So we have Garvey bonds, we have other things going on, and so they don't have the money for preservation right now. It's more like debt service.
How do you address mill scale? You take it entirely off or try to leave it on?
Yeah, we do. Now we're doing the SP10. So I think with SP10, we're taking it all off.
What about use of federal funds for washing? Do you utilize federal funds for washing?
No, that's all state funds. So we can do, with preservation work, we can do all the repainting we want with preservation funds. But all the bridge washing comes out of state funds.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.